Hey, welcome back everybody to another codezing.org project. We're going to do a level 3 project. This is going to be another cryptography one. This one is a Caesar Cipher, named after Julius Caesar, who was the first one kind of credited with using this specific type of encryption. It's kind of basic, a little similar to the simple cipher we had, substituting numbers for letters. This one's going to be letters for letters, but with a little bit of a twist. So you can find it at codezing.org/Caesar_cipher, or much easier is just going to the website, codezing.org, level 3 code, and we'll go to Caesar Cipher. So this is going to convert whatever message you put in here. If you were Julius Caesar, there will be an attack at dawn. Alright, so you have your secret message and you want to encode it, and this is the secret text, and it generates a key, and it's just swapping one letter for another. So the letter A is enciphered as K, and B is L, so on, and it gives you the entire alphabet. So you get the reference alphabet and then what the secret character would be. So if you give somebody the key and the encrypted message, they should be able to get back that there is indeed going to be a secret attack at dawn. Is that what I put in? I think so. So let's check out the code. You can click on the buttons at the bottom to get it, copy it, and put it into Spider IDE. If you don't have Spider or Python, you can go back to the website and follow the links to get it. I would guess if you don't have Python installed, if you haven't done Python before, this might not be the right level for you. You might want to head back to level 1, but let's take a look. So we're importing random again. We've done that a lot, so I won't spend time on it. We're getting input from the user, the message, and then this is going to convert the message into lowercase. And that was simply because Python views upper and lower case as different letters, and it was making, then you'd have to have like capital A equals a different letter, and capital from lowercase a. I didn't want to do that, so this message.lower converts whatever message they type in to lowercase. The next variable I created is shift equals a random integer between 1 and 20. This is going to shift the alphabet over a certain number of characters. And let's see if I can show you that a little better, because what it's really doing is just shifting the alphabet. So if you can see, we have A, B, C, D, F, G on the one side, and this is still in the correct alphabetical order, but starting with A down here. So it just shifted it forward so that A equals Q, B, C, D, E, F, G, H, I, J, and when it gets to the end of the regular alphabet, it starts over at the top with K, L, M, N, O, P, and the number of offsets. So shift of 1 would be A here, B, and then B, C, because you've only shifted the alphabet down one place. This would be a much larger shift. But that way, you don't even have to pass the entire key to the person who's going to decrypt it. You could just tell them what the shift is, and they'll know how to set up the alphabet to do the decryption. So this is creating the shift, how far the offset is. The next is create a list of the regular alphabet for Python to work with. So this is just a list, a Python list of the full alphabet. You can tell it's a list because of the square brackets, and then each text string is separated by a comma. So we have A in the quotes, B in quotes, all the way through Z. Then it's going to create a shifted alphabet. So the shifted alphabet is the alphabet over here that starts at K and goes through A. And it is going to take this list, start at the shift and go to the end of the alphabet, and then it's going to add to that from the beginning with the shift. So let's print this out. You can see what I'm talking about. So if we print just this piece. We can see that separately. So we'll print that, and then we'll print out this, and then we can down here print out the shifted alphabet. Put some spaces in there so we can see it a little prettier. All right, and then I am going to put in the triple quotes, which will just turn the rest of this into a giant comment, so Python will ignore it, so we can run just this section of the code up here. So let's move that down and we'll run it. Let's enter our message, hello, and we can see the first thing that printed is this alphabet, excuse me, alphabet from shift. So this is a selection of this list. So it's looking at the list alphabet, and it is selecting from shift to the end, because the length of the alphabet is going to be the last value. And so it started at I and went to Z. So it created the first half, and then the second piece is selecting from the beginning. If no value is specified, it starts at the beginning. So from the beginning, and then a colon to the shift value. And so that is the A through H. So it chopped the alphabet kind of in half, from the back half to the front half, and then the next step, this shifted alphabet piece, right, it's adding those two together. So it's starting with the end chunk, so it's going to start with that, and then it's going to add to that the second piece. And you can see that's exactly what it did. It has I through Z, and then it added to the list A through H. And we can even print out what the shift is, and you can see that when that shift number changes, that's what changes it. So you can see the shift was 7, so it went over 7 characters. 1, 2, 3, 4, 5, 6, 7, and that's how much it cut off. See, the shift was 4, so it cuts off A, B, C, D. Right, one more time. Then you can see this one was 19, so a big shift. So it chopped off 19 characters and then started the alphabet at T. And then combines those back together to get our shifted alphabet. Alright, hopefully that helped make sense of some of this. What looks like a little bit of gobbledygook is actually very useful Python code. So let's see, what does our next chunk do? Message dictionary. So now this is going to take the alphabet, which is this Python list, and it's going to take our shifted alphabet that we just created, and it's going to zip them together into a dictionary. So why don't we print out shifted alphabet, and then just print alphabet, and we will print the message dictionary, and you can see that it's going to quickly zip those together into a dictionary. And we're going to block out that because we're not using it yet. So if we type in hello, we can see this was the shifted alphabet. So it's starting at K, going to Z, and then starting over A to J. This is the regular alphabet, A through Z. And what this message dictionary equals a new Python dictionary that zips together alphabet and shifted alphabet. So you can see it's matching A with K, so the first regular alphabet with the shifted alphabet, B to L, C to M, and so it's creating a new set of keys and values for the regular alphabet matched with the shifted alphabet. So a quick one-line way to combine those two pieces we built into one Python dictionary. So now that we have our key, our way to match the regular alphabet to our secret shifted alphabet, now we got to use that to create our secret message. So we created an empty Python list called encoded message list, and this is going to be the new encoded message. And for letter in message, if letter equals blank, then it's going to append a blank, right? Because we're not encoding blanks. The blank is going to stay a blank. If the letter is not in the message dictionary, then we want to just encode the letter. I think this piece was for any characters, periods, colons, commas, exclamation points, numbers are not in our key. So if somebody types in a character that's not a letter, we just want it to not encode that and put it back as it was. And if the letter is in the message dictionary, we want you to look up the letter and replace it or append in the value assigned to that letter. So let's take a look here, and if we do print letter, so this will show us which letter we're looking at, and if it's a blank, it'll give us back blank, so I don't think we need to get that one. We can, I think, just watch this happen. Let's every loop print encoded message, and then let's print out a little divider here. And we can just do times 50. So this little chunk will just print out this dash 50 times. So it'll make a nice little divider for us. And let's block that out, as you can see. And let's say test message. Let's put in, you can see that it won't encode those as well. Put in some spaces, and you'll see what it's going to do with that. Oh yeah, encoded message is not defined. Line 26. Print, oh, encoded message, a list, not encoded message. Alright, so always read your errors. They'll tell you which line your error ended on and what's going on. It couldn't find encoded message. That's because the actual name is encoded message list, not encoded message. Alright, so let's run it now. And we'll put in some of these special characters. We can see it's going to build it from scratch here. So if we start, it's going to start looking for T. It's going to find letter T and replace it with M, which I suppose we should have. Let's do it with print out the message dictionary too. That way we can see what it set up the dictionary to be, what it should be doing. Let's just do test. So we can see letter. This is the key it created, right? This is the message dictionary, and it's swapping T with V, which is hopefully right. Let's see. So that's the value. The key T is being swapped with the value V. And the same thing, E for G. Let's see, the value, here we go. So the value E is being swapped with G. And it does that for the entire thing. And then, as I said, let's do task, but let's add some blanks and other characters. You can see that when it does like $, it just appends in $. When it does hashtag, it just appends in hashtag. Same thing, @ exclamation point. It's not turning those into a secret code. It's just doing the letters. When the letter is a blank, it's just putting in a blank. When it's a 2, it's just putting in 2. And that's this middle step here. If the letter is not in the dictionary, then just append the actual letter itself. And this first step too, if letter equals blank, then just append a blank. And actually, that's probably a little redundant. If you didn't put in that top part, I bet it would probably do the same. Alright, so it seems to be working. Kind of cool. Let's see, what's the last part? The last part of the code is going to be just printing it out kind of pretty. Turning it into a text string instead of a list. So without this last part, what the user would get back is this, which is a Python list, but if you're not used to that, it looks a little goofy, right? this is going to start with a blank string and then just append or add to each one of the letters. So it's going to loop through each one of these and just add it to a text string. So it'll be like N, and then add Y, add M, add N, and until it makes a nice, pretty text string that can be printed. So let's just print encoded message. Get rid of those. When we run it like that, you'll see. Get rid of that now. Test message. Oh, and I accidentally hit enter in the middle. So you can see that it is building up a text version of the list. How about print encoded message list? So we can see that. Print. Alright. You can see that it's just taking this Python list and then appending that to make a string out of it. So H plus S plus G, you can see it's building it. Every time it runs through the for loop, it's building up that until you get a nice text string. Instead of giving the user this back, we're giving them this. It's the same thing, HS, GH, space, but in a prettier format is all. Excuse me. And then we're going to print out the key. Same thing, just to make it pretty, it's going to loop through the items and then print each one of the items in the dictionary in a prettier format. Because if you didn't do that last little for loop, you do print message dictionary, and they would just get back this, which looks like a jumble. Right? This is much easier. A equals Q, B equals R. This A does equal Q, but it's hard to tell from the dictionary printout. So this was just trying to make it print a little prettier for the user. Alright, well hopefully you enjoyed that one. It's kind of cool. I think the result is really cool. Doing the cryptography is one of my favorites. Hopefully I'll be able to add a bunch more because there's tons of different ways to do cryptography. But play around with it, have fun, and we'll see you on the next one.